All right, greetings everyone. The purpose of this video is to go over an example of using row operations and Gaussian elimination, in the sense of using matrices, to solve a system of equations that contains two variables. Now, a couple of things as I go through this problem. Number one, if you haven't already learned a little bit about row operations and Gaussian elimination, then this video may not be helpful for you. It'd be this video is going to assume that you already know some of the basics of how this process works. Secondly, as I go through some of the calculations here, I will be using a TI calculator to assist me, especially because there are a lot of fractions that show up. Now, you don't necessarily need to be using a graphing calculator like a TI to be able to complete the operations as I do them. A calculator such as Desmos, or maybe a simpler scientific calculator, may also have the same functionality. So you may want to check with your calculator first. Do make sure that whatever calculator you are using has the ability to convert decimals into fractions. Okay, so here we go. To solve this problem, or to find the values of x and y in the system of equations, the first thing we need to do is take the given system and write it in a matrix. And the way we do that is we create a matrix that has two rows, since there are two equations, and it's going to have three columns, since we see in the equation that there are the two variables. So I have a column for each variable, and then a third column for the numbers. So in the matrix here, I'm going to write the coefficients relating to the first equation. So 3, -2, and then -16. And in the second row, I'll write the coefficients relating to the second equation. So the 4, the +7, and the +27. Okay, and that's the matrix that I will use to now solve for the values of x and y. My first step then is to focus on this upper left most entry, so the first entry in the first row, and I want to change that entry into a 1. And in order to change it into 1, I have to think, what could I multiply by to change 3 into 1? And the answer is 1/3. And so what I'm going to do is multiply every entry in that first row by 1/3. Okay. So once I do that then, and this is where you could use your calculator to help you if you would like, or you may be able to see in your head that if we do 3 times 1/3, that would give us the 1 we were hoping to get in that first entry. -2 times 1/3, that'll give us the -2/3. And then -16 times 1/3, that gives us -16/3. And then the second row we are not doing anything with in this step, so we're just going to leave that as 4, 7, and 27. All right, so we've accomplished our goal that first entry in the first row is now a 1. And we can use that then to figure out or to eliminate all the numbers below it, which in this case, there's just the single number, just the 4 in the same column. And so what we do now is we think to ourselves, what could we multiply 1 by so that when we add it to that 4, it would make the 4 go away, essentially make it 0. If we think for a second, the answer we come up with is that if we multiply by -4, right, we would have 1 times -4, that's -4. If we then add that to that +4, that will be 0, right? And so that will help us eliminate that entry. Now, what we need to do then is multiply every entry in that first row by the -4. Okay, and so we'll go ahead and do that. So I'll do -4 times this 1 right here. Okay, that'll give me a -4, and I'm going to write that number down below because I'm not actually going to put that number in the matrix. I'm going to also multiply -4 times -2/3, And this is where if you want to use your calculator to help you out, you can do this like this. So I would do, and let me clear my calculator out here. I would do -2/3 times a -4. Notice that gives me a decimal answer. If you're using the TI, I can then hit the math. That first button there will make it into a fraction. And so we get that it is 8/3. So in this, for that second entry, that's going to become 8/3. And then we'll do the same thing with the -16/3. So here we'll do -16/3 times the -4. In this case, we get 21.3 repeating. Again, we'll change that into a decimal. It becomes 64/3. Okay, so this is 64/3. All right, and then what I'm going to do is add each of those numbers entry by entry to the corresponding entry in the bottom row. Now, as part of this process, I'm not going to change the top row. So even though we multiplied everything in the top row by that -4, those entries actually will not change. So we'll have a 1, a -2/3, and a -16/3 still in the first row. And then again, I want to add entry by entry each of these numbers to the numbers in the second row. Okay, so when I do that, I would do the -4 plus the 4 in the first entry. That'll be 0. Next, I want to do the 7 plus the 8/3. I'm again going to go back to my calculator, allow it to do the work for me. So I'll do 7 plus 8/3. Get that answer. Again, I'm going to convert it back into a fraction. That'll give us 29/3 as the second entry in the bottom row. Okay. And then we do the third entry there. Again, the 27 plus 64/3. It's 27 plus 64/3. That gives us that number, which as a fraction is 145/3. Okay, so the second row has now become 0, 29/3, 145/3. But most importantly, notice that we've eliminated the entry in the first column, right? It's just a 0, which is good. Okay, so now having accomplished that, we've changed the upper leftmost entry to a 1. We've eliminated all of the entries below it. We now move to the second row, the second entry. So this 29/3 here. We also want to change that entry to a 1. Okay. And we can multiply by something, or we could also divide by something. Either way you want to think about it, to change 29/3 into 1, there's kind of two approaches. We could divide by 29/3, right? Because if you divide a number by itself, you get 1. Or we could multiply by the reciprocal, which would be 3/29. Because if we did 29/3 times 3/29, we could do some cross canceling here. We have a bunch of 1s. We multiply, we'd get 1/1, which is just 1. All right, so either way we want to do it, I'm going to go ahead and divide by 29/3. And again, we're going to apply this to every entry in that third row. Okay, so even though our point here, or our purpose is to make that 29/3 into a 1, every entry in that row needs to have the same thing done to it. Okay, so I'll write my new matrix down here. Again, I'm not changing the top row, not doing anything with the top row, in fact, in this step. So I'm going to leave all of those entries as they are. I'm going to go ahead and make this a little bit larger. Yep. Okay. And then I'm going to divide every entry in that going to be 0. 0 divided by anything is 0. If we do 29 over 3 divided by 29 over 3, we're dividing a number by itself. We know that's just going to be 1. And so the most math we have to do here is with the 145 over 3 divided by 29 over 3. Again, we'll let the calculator do the work for me here. 145 over 3 divided by the 29 over 3. It turns out that that comes out to be a nice round number of 5. And so that last entry there ends up being 5. And notice what we've accomplished here, again, is we have the 1 in this column. And in fact, we've also found the variable for y, or the answer for y, believe it or not. It's going to end up being 5, and we'll see in a few minutes why that is. So that's nice. And cool. All right, so we have now accomplished our goal of making the second entry in the second row 1. So now we're going to kind of do the opposite of what we did in the once we had made this first entry in the first row 1. So we now want to eliminate all the entries above that 1, which in this case is just the negative 2/3. And so again, we want to think, what would I have to multiply 1 by so that when I add it to negative 2/3, I would get 0. And the answer there would be multiplying by 2/3, positive 2/3. And again, just like we did with the first row, we're going to multiply every entry in that second row by the 2/3. Okay, so I'll do the 0 times the 2/3, that's just a 0. The 1 times the 2/3, that's just 2/3. And then the 5 times the 2/3, you go ahead and plug that into your calculator. When you do, you'll get 10/3. Okay, and then we're going to add those again, entry by entry, to each of the entries in the first row. Now, as we're doing that, we're not going to change the second row. So even though we multiplied every entry in that second row by the 2/3, none of those entries will change. And then again, we're going to add entry by entry with these pairs here. So we'll do the 0 plus the 1, that'll be 1. 2/3 plus the negative 2/3, that will equal 0. Again, that's why we chose that. Then if we do the 10/3 plus the negative 16/3, you might be able to do that one in your head. We can also do it in the calculator. So we do 10/3 plus the negative 16/3. Okay, turns out that that also ends up being a nice round number. So we get negative 2 there. Okay, so this last entry in the first row will be negative 2. And at this point, you hopefully recognize that we have accomplished getting our matrix into that row reduced echelon form, because notice in the first two columns, we have 1, 0, 0, 1. And then we have numbers in the last column there. And so this now allows us to complete our goal, which was to find the values of x and y from that equation we started with. Because remember that the first row or first column here stands for x, second column stands for y, third column is numbers. If we now convert this information back into equations, what we get from the first row is that 1x equals negative 2, so we don't write anything for the y because there's just a 0 corresponding to that entry. And then from the bottom row, we would end up with 1y equals 5. Again, we don't write anything for the x because notice there's just a 0 there. But each of those simplifies nicely to just x equals negative 2 and y equals 5. And therefore, we have now used Gaussian elimination to find our two answers here. All right, that's it for now. Thank you for watching.